Seeing the demo portal. So this is a user configurable dashboard. So before I get into the dashboard, let me first explain it is a portal where each user gets their own top level organization. So if you're setting up for a customer, in the case of this Shoreline demo portal, we have the Shoreline demo as the top level. And then underneath it, it has different demonstrations of different kind of user or different areas that we serve, different verticals. You can set it up as a company, like this company here. They have different plants, Plant 66 in Banning, California, and Plant 97 in Corona. So it's up to the user how they set up their org and their sub-org structure. Right now, it's limited to a 2-level, so that you can have a top-level organization that represents the entire org. So if you have like a large oil and gas company, for example, and then they have different sites across different regions, those would all be populated under here in sort of a flat structure. So that's the org and sub-org structure. This is a private database. So each one of these top-level organizations is its own private database, and that database will be in region for that customer. This is a simple example of a dashboard. This is a predictive maintenance dashboard that shows you how many assets are in high alarm, are healthy, or in critical alarm. Gives a quick top-level summary of which site, which assets, and how old the alarm is and what the severity is. So that list is here. You can click through it and it will take you to the alarms page. You can also do trend charts. So if you wanted to chart, these are just overall vibration trends. This is total vibration energy or broadband energy coming off the accelerometer. This is traced over time. This is surface temperature over time. This particular one with the flat trace, this is inside of an air handler unit. So it's just kind of charting a very constant temperature of the airflow inside the unit. This is total vibration energy. You've got this one seems to be going crazy. And then you have these that are kind of running at a constant level. So you can set these up. They're all user configurable. You know, you've got, you can view all dashboards. You can assign them to different users. So you can have some assigned to a particular role. If you have a C-suite role, C-suite members can come in and look at dashboards that are relevant to them. You can set it up for a technician role. So somebody that wants to see things like the strip chart that we were just looking at with the data trends, that's more of like a technician or an expert role that wants to be able to dive in and look at these traces. And you can organize these and set them up, configure what your default dashboard is, where you want to land when you come into the portal. Going into the alarms. So this is the alarm table. If I open this up, so this particular case is a fan imbalance for this east exhaust fan. It's occurred 248 times since it was raised in the demo portal. Diagnosis in this case is critical imbalance in the fan shaft, possibly due to accumulation of material or wear on the fan blades. These two fields, the diagnosis, possible cause, and the recommended actions, are seeded from the physics models and from the machine learning. So there's a default thing in the template that this comes from. And over time, as it learns more about this, it can update and modify these recommendations. The analyst notes comes from an expert such as yourself who has the technician role. You'll see alarms. Unfortunately, all of these are in the WIP state. There's none in review state. But if any of these alarms were in review state, I'll have to go through and clear these because Amitabh fiddled with my demo portal. But I need to put some back in review state. What it means is they will not be visible to the end customer until they're released from review to the end user. And that transition from review to new state, what you do is you would click on this, then you would click on new. And when you click on new, you would then enter the analyst notes. Those analyst notes provide an area for the expert to add additional color on top of what's observed by the machine learning and the diagnosis that the system is doing. So in this case, they may have gone and looked at particular data, and they may say that we've confirmed the imbalance by reviewing the vibration signature. Because they know the plant or the facility, they can come in and recommend maintenance, come in between first and second shift, look to see if they could attempt cleaning to resolve the imbalance, or look and see if there's any kind of bent shaft or any other problem that's causing this particular imbalance in the fan. And then once they're ready, they can come back here. They can change it from acknowledged to work in progress. That indicates that they've moved it from the act state into the, so I didn't cover the act state. So if it was If you had released it to new, then the customer would acknowledge to see that they have, or show that they have seen the alarm, and that they're taking a look on it, doing their initial inspection and their triage. And then after that, they would change it to in progress when they decide they want to repair it. If they have looked at it and confirmed that it's a false alarm, they would click false. And at that point, they would enter the reason here why it's false. That goes back into the learning. So you as the analyst can see the feedback from the user, and the system can see the feedback from the user. And then they can fix it. If they choose fixed, it's the same thing. Enter the information, explain what they did to fix it, what parts were changed out, what the actual problem they found was, whatever it may be. If it's different than what was observed here, this can be used later to improve the alarms. So that all goes back into the system, into the learning and the maintenance history for that asset. That's used in time to build up sort of a virtual expert in the cloud that allows it to understand that individual asset better over time. Digging in a little further, this is how the assets are organized. So this is the asset tab on the side where I was. This is the alarms tab. So that's here. Alarms has asset alarms and sensor alarms. The sensor alarms are if there's something going wrong with the sensor, like a battery is going out or something else, that comes up in the sensor alarms. So here's the assets. One thing to note, these are all kind of organized flat. So these are all powertrains. Our asset organization is by powertrain. So this air handling unit consists of an entire powertrain. This one's a fairly simple one. It just has a driver. If you look at the powertrain editor, it has a name. It has an RPM range. So this is the range that the VFD can control the motor. It has an override for speed detection. So if you have a tachometer that comes in on a different data point, you can choose a data point that you can wire in to be the speed control for that. That can come from your Pi historian. It can come from another data source, or it can come from the sensor itself. You can manually override the speed call, or you can use our algorithm. Our algorithm is pretty accurate for most machines, so it will pick up the speed provided you enter the correct RPM range for the VFD control. In this case, it is a component, serial number, it's an electric motor, AC motor, and it's a ball door. So we have A.O. Smith, ABB, ball door, Century Electric, WEG, Crown Titan, Davis. So lots of different models. And then you have all the different models of ball door in here. So there's many, many different ball door Reliance. If it's anything that we've missed in our library, it's very quick for us to use the component compiler to create a new model. So ball door is really easy. If there's anything missed in the library, it takes us a matter of minutes to go out and populate a new motor. The sensor mount points, depending on the size of this motor, we recommend drive end and non-drive end. If it's a small motor, usually under 25 horsepower, we only do the drive end of the motor, or one end of the motor. It doesn't matter whether it's drive end or non-drive end. Both mount points are always available. And then you as an expert, when you're installing, you may find that the non-drive end is the better location for you to mount on a pump or whatever that you're looking at. In the case of this, if I dig into this view, this is that asset view. So you can see it's a ball door motor. It shows the drive-in and non-drive-in sensors. And it shows you that this one currently is an alarm. It's showing you that it has a resonance that it's noticed. And it's got some other information on it. So it lists all the asset alarms here in this asset view. And then you have the two sensors. You can see the status of the sensor, critical or high alarm. You can drill further into the asset dashboard or the sensor dashboard. Sensor dashboard shows you the total vibration energy trend for that, shows you the last surface and environment temperature and humidity reading, and it shows you the quality of the cellular signal, if there are any sensor alarms or any problems with the sensor, and when to replace the battery. This is also available in the dashboard at the top level, so you can see all the battery management for all sites. What I'm switching to now is the traces. These show you the overall vibration trend over time. This is surface temperature, environment temperature, humidity. These are narrow bands. These are broadband. You've got daily battery usage accumulator, and you've got additional points that you can bring in here. You can see the raw accelerometer traces, all the narrow bands. You can add in additional sensors, such as the airborne or structure-borne microphone, the analog input on the sensor. We may have mentioned that the sensor has an analog input. It's a 420 milliamp input. So if you have additional process data that you need to get in from the field where you don't have a sensor instrumented today, you can install a temperature transmitter or flow transmitter, any of these transducers and transmitters to bring that 420 milliamp signal into our sensor, into the front. And then we can take that up to the cloud and we can do scaling on it here and present the data. We also have a bunch of diagnostic data points for what's going on with the sensor, what's going on with the cellular signal strength, etc. This data, by the way, is accessible to you and to the customer. So they can export all of this data. So you can go through and select any of these data points, including the diagnostic data points. So if you're bored, you can see what your cellular signal strength looks like day to day. All the ones for the narrow bands, these are narrow bands where it's breaking it down into the different bands and frequencies relevant to this AC motor. And it's displaying that here. You can download and trend that data. You can use it in your own spreadsheets or however you want to look at that data. Show you the settings here. You can come in. We manage the firmware for you, so you don't need to worry about maintaining the firmware versions. It'll show you the SIM information here. Again, we manage the SIMs and the cellular provider, so you don't need to worry about this. This shows you where the sensor was installed. So when you're installing with your mobile phone, it uses the GPS from your mobile phone to tag where the sensor is installed and located. And then you take 3 photos when you're installing. The overall machine view, in this case, it's an air handling unit, so you can see the 2 sensors on the motor, and then the fan. The fan is directly mounted on the end of the shaft. And then the nameplate of the motor. So this information gives you the ability to look at the install after it's happened, to verify that the sensor locations are correct, to verify that everything is as you would expect it to be, verify motor information, make sure the correct model is deployed. This is useful to have this repository of information. So when you're doing analysis or the customer's doing analysis, they can go look and say, okay, yeah, I know where this asset is. I recognize that. So if something gets misnamed or mislabeled, they can look at the photos and they can understand, what goes where. There's schedules you can set up. This cloud update interval is when the sensor is scheduled to check in. It can be check in once a day, every day. You can have it check in, once a week. So if I want it to check in Monday at midnight, I can set it like that. Our default is to have it check in once a day and upload all of the observations that it's recorded throughout the day. It will also check in when an edge rule is triggered. The edge rules are designed to watch for when the machine is going out of compliance or out of some normal operating mode. It will then upload the data automatically to the cloud. The cloud will then take that data that's uploaded and do further processing through the physics models in the AI/ML to produce alarms and results. This logging time, this is when full samples are taken. These full samples are as if you went out with a handheld vibration analyzer and you probed the machine. And this is as if you took one at 1 a.m., 7 a.m., 1 p.m., and 7 p.m. Now, one thing that we're working on doing in the system right now, these samples are fixed, meaning it takes them at 1, 7, 13, and 7, or 13 and 1900 hours. You obviously know that the machine may not be operating at those times unless it's continuous use machine. So what we're doing is we are making it sample on activity. So if you were out there with a portable analyzer, you're obviously not going to sit there with the machine that's off and use your analyzer to take a reading. There's no point. So we're fixing that where our sensor is going to go out and we may schedule it to take these times, but what it will do is start waking up at that time, watch for machine operation. As soon as it captures machine operation, it'll go back to sleep and it will pick up at the next time. So the sampling interval here, this can be set on battery down to every 10 minutes. This is when it wakes up, it takes that intermediate sample, is looking for activity. So every 10 minutes, it can be monitoring your machine. So this is watching for any kind of aberration from normal activity. So here's what we have set up on this one. We're taking the 800 ODR. So this is the output data rate from the accelerometer. So 800 hertz sampling rate is what this means. So this goes 0 to 400 hertz. This goes 0 to 1600 hertz. And this goes 0 to 12800 hertz. The resolution is 2048 lines of resolution. So that means with 400, what am I trying to say? 400 hertz, 2048 lines is approximately 0.2 hertz per line of resolution at 800. This one is approximately 0.8 hertz per line, if I recall correctly, and this one is 6 hertz per line. So that's the resolution that we have with our ODRs. And in this, in this case, we're taking these 3 samples. So we get this high resolution, low frequency. So this gives us good data around running speed. This gives us running speed and harmonics, and this gives us a lot of high frequency. So this is looking at early defects in bearings, pump seals, and other things. We also have the structure-borne microphone, which has 40 kilohertz top frequency with the 80 kilohertz sampling rate. It'll do the 800 in all 3 directions, X, Y, Z. So it's a simultaneous sample. It's a triaxial accelerometer. So it samples the 3 in phase with each other, and that's important because when I want to do phase measurements on that single point to look for an imbalance at a single point, then I want to have them in phase. So it will do an 800 XYZ, it'll do a 3200 XYZ, and then a 25600 XYZ. So it does these 3 sequentially, but it's doing XYZ in parallel. Okay. And this, again, is just the example. So again, this was the ball door motor. So, this guy. So when we deployed that model, with that model, you get these bands, you get the rotor bars, you get the shaft speed, 1x, 2x, 3x shaft speed, you get 1x, 2x of the rotor bar frequencies, you get the line frequency if it's configured for a fixed line frequency, and you get the bearing information, inboard and outboard bearings, slot pass frequencies, etc. For this particular one, there's an additional patch on top of it because it has a fan stuck on the end of the motor. It has a 12-vane fan, so it has a 1x and 2x of the blade passing frequency of that fan. Moving on here, so this is in the workflow. This is the analyst view of the vibration trend over time, as well as the signature. So this is down here, I've got it in CPM right now. So this is CPM or RPM, however you want to look at it. This is currently in G. You can look at it in G, inches per second. At one point in time, we had millimeters per second, but we were servicing the US market first, so it was fixed at inches per second. We can certainly add millimeters per second back in. So we do acceleration, velocity, displacement, and then dB. So we have those options here. We have peak, peak to peak, RMS. And then we have CPM, hertz, and orders. So if I want to view this in orders, which, if you're like me, you want to see things in orders because you want to be able to look and say, okay, what's my first order, second order, third order is down there very tiny. This one's not third order. So that one's probably coming from a bearing or from some other source. You can come in here and you can use the analysis parameter set. So you can mark the bands like 1x, 2x shaft speed. And then since you saw that thing was, perhaps a little bit higher, maybe it's a bearing. And you can browse any of these points in time. Any point that's filled in is a point that has information behind it. So you can click on any of these to view the historical view. Now, if you want to look at a trend, like there's some emerging trend that you have with your machine, this button here is the waterfall. So if you click on that, it'll take you to the waterfall chart. So then you can look at it over time. You can see the date and time here. The newest sample is in the back. The oldest sample is in the front. So that way, if you have some emerging trend that's increasing, it doesn't get masked by the samples in the front. And you can kind of fiddle around with the levers that we have here. Sorry, I had to move the presentation thing out of the way. But if you kind of zip this around, you can kind of view it from different angles. Look from different sides, see what's going on, see if there are any weird bumps that are coming up anywhere. Otherwise, it's operating pretty stable. And this is currently displaying in orders. Again, you have hertz, CPM, and order. So that way you can normalize it so your 1x running speed is always locked dead in there. So you can see anything that's moving around out here that's not related to your running speeds. So it's a very nice way to view the data and look at a trend over time. And I'd mentioned before about looking at the balance plots or the orbit plots. So we have orbit plots because we take the data XYZ simultaneous. So we're able to plot that information and look at anything like this where you have something that has, basically this is looking at its roundness. 90 degrees is a perfect circle. So this number in degrees or radians tells you how circular this actually is. And generally we look at something that's, I think 60 to 120 degrees is we call circular. So this one's showing like a little bit of an orbit to it, which means that that fan blade probably has a little bit of imbalance to it. And again, just like with the this trend back here, you've got the TVE chart at the top. You can use this to explore different samples in time. So if you can go back to this one probably was when it was off. I don't think there's any data there. If I click on this one, then you can see this one doesn't have quite as much of an orbit. It has lower energy. Okay. And then the final thing that I have is user management. You can set up their alerts, whether they receive alerts through email or through the application. There's a mobile app that comes with our solution. The mobile app allows you to provision the sensors to the cloud. It also allows you to do the same analysis in field, where you can come out and you can do the vibration signature by pressing the button on the sensor, take a live reading, and it will actually upload that reading to the cloud portal. So if you have remote assistance, an analyst in the back office can look at the data and do some analysis to support the guy out in the field. So that's a useful feature. It allows you to take an immediate reading, and you can take readings before, during, after a repair, and you can look and confirm that whatever we were seeing, whatever was happening has been cleared up, the issue has been resolved. So it's a very, very useful diagnostic tool. The app also can receive any of these alarms. So if there are alarms that are coming through, this app notification allows those alarms to come instantly as a notification on your mobile phone. So you'll see that notification and you can act on it immediately. And adding a user is quite simple. You just enter their name here, whatever their name is, name@org, org.org, and then their role. And typically an admin is somebody that would work, and you can put them in the suborg, or you can put them at the top level organization, so they're members of all the orgs. So it's up to you how you want to put the user. Apart from that, you can manage the user levels, etc. There are additional org settings, customization you can do, role customization, API tokens that you can do. API tokens allow you to create a token or a key that you can use with our API to integrate. So you can do data exchange. You can integrate with the alarms, so you can pull all the alarms down. So if you want to integrate with their CMMS system and raise a work order when an alarm comes in as new, then that can be done as well.